Welcome, geometry students, to section 6.5, condition of rhombuses. This is kind of like an extension of 6.4. You'll notice here I have a great drawing here, digital drawing made by Mia Castellon. She was one of my students last year, so she does an excellent job with all of her art. So thank you, Mia. We love this drawing for a January theme, and we're going to pick it up right where we left off. Now, I came up with these names because the book has weird names like 612 theorem and stuff like that, which I think is ridiculous. Really what you want to think of with these ones is, these are converse theorems. So everything we learned in 6.4, these are the converse theorems. What do we mean by that? Well, in 6.4, we learned that if something is a rhombus, then we know certain properties about the rhombus. Now we're going to say, okay, if we have a parallelogram with certain properties, then we know that we can classify it as a rhombus. This is all about classifying shapes. So in this one, if ABCD, okay, is a parallelogram, and I'm going to use this symbol here, that means parallelogram, and as you can see in my drawing, AC is perpendicular to BD, okay, 90 degrees right there. Then, I'm going to go ahead and add it over here. Then we can say that ABCD is a rhombus. Okay? So we're just going in reverse. Instead of knowing that it's a rhombus and that its diagonals are perpendicular, we're saying we have a parallelogram whose diagonals are perpendicular. We know it's a rhombus. Okay? So just think converse for these properties. These are converse of essentially 6.4. So we have this theorem. ABCD is a parallelogram. Okay, we have another one. And AC bisects the vertices. So all the diagonals bisect. I'm going to put diagonals bisect vertices, okay, or the angles. Then we know that it's also a rhombus. Okay, so let's go ahead. Oops. It would be the same thing here. This diagonal would also bisect. We need to know that. Okay, so 1, 2, 3, 1, 2, 3, and then we had 1, 2, 3, 1, 2, 3. Technically, these angles are equal. Okay, but we also know that then ABCD is a rhombus. That's going to be a common thing. ABCD is a rhombus. All right, parallelogram congruent diagonals theorem. This one's different. This isn't a rhombus. Okay, so if ABCD is a parallelogram, okay, same deal, and its diagonals are congruent, then we know what? And first off, where is the name for this shape? I don't know why I forgot that. A, B, C, D. Maybe I should give it something a little bit more original. A, B, C, D. Then, what do we know about this guy? First off, I got to add these in here. Boom, 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 boom. Then A, B, C, D is a rectangle. Okay, it's a rectangle, not a rhombus necessarily. Okay. All right, so for what values of x is the figure a rhombus? Well, we know that the angles need to be bisected. Okay, it looks like a parallelogram. We would need this to know for sure. But we want these angles to be equal. So we set them equal to each other. It's as simple as that, and then we solve for x. So we subtract 4x, subtract 4x. In my opinion, this is just kind of like this whole chapter just fishing for some extra algebra practice. But I get it. You know, it's a math book. It wants us to understand this. So hopefully you're able to follow along my process there. I got x equals 5, and that's it. That's all it's asking for. Short section. Hopefully it's just a little bit of a refresher. 6.6 is pretty good, so stay tuned for that. But thanks for joining us. I appreciate you watching. Hope you enjoyed it, and I'll see you next time.